Welcome. Today we're going to explore neural networks, not just as a buzzword, but as the foundational technology reshaping how machines perceive, reason, and decide. We'll trace the journey from the biological spark that started it all, through the mechanics of how these networks actually learn, to the applications transforming industries today, and where this is all heading. Every neural network traces its lineage back to a single audacious idea. What if we could build a machine that thinks like a brain? Let's start at the beginning. Cullow and Pitts weren't engineers, they were philosophers of mind. Their 1944 paper asked a radical question: can logic be embodied in a network of simple units? That question launched an entire field, even if it took decades to catch fire. Think of each layer as a filter. The first hidden layer might detect edges in an image. The next assembles those edges into shapes. Deeper layers recognize objects. No single layer understands the whole picture. The intelligence emerges from the stack. Understanding the architecture is one thing, but how does a pile of random connections become a system that can recognize faces, translate languages, and detect cancer? That's the magic of training. This is the heart of it. A neural network starts knowing nothing. Every weight is random. But show it enough labeled examples: cat, not cat, cat, not cat, and the math of backpropagation slowly sculpts those random values into a pattern detector. It's brute force learning by gradient descent, and it works astonishingly well. Neural networks aren't theoretical. They're in your pocket, in your hospital, in your bank's fraud detection pipeline. The same fundamental architecture, trained on different data, can drive a car or diagnose a tumor. That versatility is why they've become the dominant paradigm in machine learning. I want to pause on this quote because it captures what makes neural networks genuinely important. Not speed or automation for its own sake, but the ability to augment human judgment in life or death decisions. After 70 years of fits and starts, neural networks are no longer an academic curiosity. They are the engine of modern AI. And the architectures being designed today will power discoveries we can barely imagine. The question is no longer whether they work, but what we choose to build with them.